All right. Now, as you would think, when you have well, let me ask you this. Are you having trouble following me around?
No, so I've got the whole.
All right, cool. So if you have an equation like this, the objective is to isolate the x. And in doing so, what you do is the opposite of what's being done to the x. Very elementary kind of. You see there's a 1 being subtracted there, so what are you going to do to undo that? You're going to add 1 to it. And then the variable is multiplied by 2, so to undo that, you're going to divide by 2. Well, if the unknown quantity is buried inside of derivatives, how do you think you undo that?
Integrate.
You integrate. Yeah, that's exactly right. So what I'm going to do is I'm going to go ahead and integrate this equation. With respect to t. Why am I doing it with respect to t? Well, the answer is because the derivative is with respect to t. Right? I'm trying to undo the derivative. So if you integrate the second derivative with respect to t, what do you get?
Velocity.
Yes, or the first derivative.
Yes.
Is everybody okay with that? You integrate a second derivative, it becomes, because the integration just undoes the differentiation here.
Plus c.
Plus c, good. Now actually, you do get a plus c on both sides of that equation. But what am I going to say next?
They're different c's.
They are different c's, but if you have 2 arbitrary constants, if you bring one to the other side, the difference of 2 arbitrary constants is what?
An
An arbitrary constant, exactly, right? So while there technically is a plus c coming out of each of these, you only need 1 to represent it in total, because you can move the 2 c's together. Okay? And now, as Christian pointed out, what this actually is the velocity. This tells us that the velocity of this object is gt plus c. Now, if you look at that, the plus c came about simply as a mathematical artifact, right? It was the constant of integration we got. But in reality, you can specify what that constant of integration is in terms of the physics of this problem. Remember, there were 2 parameters that I gave you up front, some initial velocity and some initial height, right? H and v naught respectively. See, what this condition amounts to is that at time t equals 0, the velocity of the object should be whatever velocity we give it, the v naught. Well, if you use this condition, and by the way, this is referred to as an initial condition, commonly referred just an IC, initial condition. So if I use this condition, can anybody tell me what the c is equal to?
V naught.
V naught. That's exactly right. So what we're left with is the linear function in time representing the velocity. Again, we have to take it a step further, right? Because what we actually want to do is find the position function. So how do I find a position function?
Integrate again.
Integrate, yeah, that's right. Just integrate.
1/2 gt squared.
That's it. Plus another constant of integration. Remember, every time you integrate, that. So what I'm saying is that constant of integration is more than just a mathematical artifact. I marginalized it before to impress upon you that I was really being ironical about it, right? Because they have physical interpretation. So when you actually make measurements in a laboratory and use, say, this Einstein's field equation, Newtonian field equation, whatever governing chemistry, biology model you're using, those arbitrary constants have physical meaning if you actually go back and look at whatever mechanics are playing out the problem. So the initial height, this h, again, the information pertains to an initial condition, specifically this one, right? Because at time t equals 0, the position should be h. That's where it's thrown from. So if we use this condition,
C equals H.
That's right. What this gives us is a position function. And then, of course, from there we can answer the question. The question was, at what time does this object strike the ground? Well, I can do that simply by setting y equal to 0. Yeah. There is a plus minus in there, but realize I threw the minus away for symmetry because that would give a negative time. So maybe, yeah, that's it. And I guess, just to emphasize the point, do you see that the time is measured in terms of these observed quantities? In other words, every one of these quantities you see is something you can measure, right? There are no arbitrary constants or that. You know what the initial velocity is, you know what the height is, and the g is the number you guys were playing around earlier, 32 feet per second squared or 9.8 meters per second squared, whichever it might be. So that's the idea behind a differential equation. And like I said, they're the most useful types of equations because they're the things that actually give us the laws that we know. So for instance, when you take a physics class, one of the things they make you do is memorize this. Right? Likewise, they make you memorize this. Right, the velocity is g equals v naught. But every single physical law, whether it's physics, chemistry, biology, doesn't make a difference. Every one of those come from what we call a mathematical model. The idea is you create some model. In this case, we leaned upon Newton's law. That was our model, right? That's what we kind of based the whole calculation on. So if you were in, for example, quantum mechanics, there's another governing model called the Schrodinger equation, right? Or sometimes in mathematics, or a lot of times actually in mathematics, we have to create our own models. So let me do one that's more biologically oriented, just to make sure I don't stay in physics forever. But I probably will do physics just because. Let's try another one. Okay. Did I ever tell you guys about that really gross UCF bio experiment that we did?
Yes.
About how you don't
So,
make public bathrooms.
Yes, that's the one. The
Oh,
one that
yeah.
scarred me for I will need therapy as soon as I can afford it. So yeah, let's do one like that. Let's suppose.
You what that?
You observe.
Observe. Oh, sorry.
Oh, you observe. Yes, you observe.
Oh.
Now, when you guys have encountered these problems in biology classes, chemistry, whatever, usually they give you numbers.
Mm-hmm.
But I'm doing this intentionally